Alright, we're going to look at section 2.2, graphs of functions. The first thing we want to look at is the vertical line test. Keep in mind a vertical line is an up and down line, as opposed to a horizontal line which goes from left to right like the horizon. So if any vertical line intersects a graph in more than one point, the graph does not represent a function. That is what the vertical line test says. So in this first example, we've got 3 different graphs here, and on each one we want to figure out if they're functions or not. So on the first one, if I draw a vertical line anywhere on this graph, so it helps just kind of to pick a point. Like if I draw a vertical line right here, that only goes through my graph at one spot. So this is a function, because anywhere I draw that vertical line, it'll only go through at one spot. On the second one, if I draw a vertical line like here in the middle, look at that, it goes through 2 different spots. Because it went through at 2 different spots, it's not a function. And then on this last one, this one looks weird, but it's very similar to the first one. Anywhere you pick that you draw a vertical line on here, it will only go through the graph once. It won't go through more than once. So this one is also a function. So now we're going to look at graphs of functions, and there's information that we can get. Remember that each of the points on this line kind of thing we've got going on here, we can represent as like an x comma y. Like for example, this point up here, right up here, that's the point 2 comma 5. Okay, so that's helpful to remember that 2 is our x value, 5 is our y value. For part A, it says f of negative 2. Well, we talked about yesterday f of x and what that means. Well, so this negative 2 is where x is. So it's telling us x equals negative 2, and it wants us to say what y equals at that spot. So at x equals negative 2, that's right here, our graph actually goes through the x-axis at negative 2. What is the point there? Negative 2 comma what? Well, it'd be comma 0. So what it's asking for when it says f of negative 2 is it's asking what is the y value when x is negative 2. So our answer would be 0, because at negative 2 our y value is 0. And then the next two are similar. So f of 1 is saying our x value is 1. That's our answer is 0. On B, it says our x value is 1. It wants us to go up to our graph and look at this point. Okay, that's the point 1 comma 3. And so if the x value is 1 like they're asking us, then our answer is 3. F of 0, we need to find 0 for our x's, so 0 would be right here. Well, that's where 0 is. That's not where our 0 is for our graph. Sorry. So at x equals 0, we'd come up to our graph, which is right here, and look at this point. That's the point 0 comma 1. And so our y value is 1. D and E ask us to do the opposite. Now they're saying to find the x value when f of x equals 5. F of x, most of the time, like, we can replace with y. Sometimes that's actually helpful to do, and sometimes it's not. This is one of those cases that it's helpful to think of this as y. It's telling us y equals 5 and wants to know what x would be when that happens. Well, our y's are up and down, and so our y's are 5 right here at this point we actually already found. And so that means if our y is at 5, our x value, which is what they're asking for, is 2. So then it says, what is the value of x when f of x equals 0? Well, when y is 0, that happens down here along the x-axis. And so if we look, there's actually 2 spots where our y values will be 0. There's negative 2 comma 0, and then there's also negative 4 comma 0, which is this point right here. So we have 2 answers. X can equal negative 2 and x can equal -4. Now, to get some information from graphs, we're going to look at domain and range for graphs. And so if we see a closed dot, which looks just like what this bullet point looks like, our bullet point here would be a closed dot, it means the graph is equal to at that point. If we see an open dot, like this bullet point, that means the graph is not equal to that point. And so we're going to be writing this stuff in interval notation. And so when we see a closed dot, or when we're equal to, we need to put brackets. When we see an open dot or something not equal to, we need to put parentheses. We need to keep in mind we're going to be dealing with some infinities, like we might say at some point that our domain is all real numbers, which is from -infinity to +infinity. And notice that I put parentheses around this, and you will always have parentheses for infinity, because we can never actually equal infinity, and that's what brackets mean, is equal to. So we can never actually equal infinity. It's not actually a number, it's an idea. So we put parentheses around infinity. And then remember from yesterday, our domain is our x values, our range is our y values. So, example 3 here. Use the graph of the function to identify its domain and range. So we want to start off by looking at our x's. And so it might be helpful for us to label these points as an x and a y. Like the point down here at the bottom is the point -2, -3. The point up here would be 0, 1. And what we did yesterday when we looked at ordered pairs is we separated the x and the y values. And so that's what's going to happen here, is that if I'm talking about my domain, I'm saying, what x values do I have? My x values go from here to here, where I've got my orange lines drawn. So our domain goes from -2 to 0, because those are the x values that it goes between. Our -2 has a closed dot, so it gets a bracket, and at 0, that's an open dot, so it gets a parentheses. For our range, we would do the same thing, but with our y values. Now we're talking about up and down. So from here to here is our range. So that bottom value is going to be -3. It's closed dot, so bracket. And it goes all the way up to our y value of 1, where it's not equal to, because it's an open circle, even though I kind of covered it up. So -3, 1. Another type of problem they could give us. These arrows, remember that means that this graph keeps going in the same direction forever and ever. And so also this way, it'd keep going forever and ever. And so this is where infinities are going to come into our domain and our range, because for our x values, if we look, there is no place on here that I can draw a line and say, oh, my x values stop there, because my x values aren't stopping at all. They continue going to the left because of that arrow, and they also actually continue going to the right, okay, because this is going up and to the right. Well, that means that my x's will continue. I would continue being able to travel this way forever and ever. So our domain is actually all real numbers, since nothing is stopping our graph in either direction, left or right, and so we write that in interval notation as -infinity to +infinity. Our range would be from down here, because that's the bottommost y values. I won't ever end up with y values down here, okay? There's no part of my graph down here. It starts at 2, and it's actually equal to 2. Like, we can have a y value of 2 on our graph, so that means, oops, that we'd put a bracket around 2. And then it goes up forever and ever and ever, because it continues going this way, which is up and to the right. It keeps going up forever and ever, so there's nothing stopping our graph on top, so it'll keep going to infinity. This last one looks kind of weird, but is actually probably the easiest of these because of what we did yesterday. If we look at each of these points, because they're just points, we're going to have to list the x values and the y values like we did yesterday. So like this point has an x value of -3, so -3 is part of my domain, and this one has an x value -2, so -2 is part of my domain, and so on. 0, 3, 5. So all 5 of those numbers are part of my domain. No other numbers would work. My range actually is even smaller because all of these have a y value of -3. So my range is simply -3. Technically, we should probably put squiggly brackets around this because it's a set of numbers. So there you go.